this is a very informal talk. I've got 10, maybe 15 minutes of actual content. So if there's questions at any time, shout them out, raise your hand, and we can answer them as we go. Calvin or Cameron will run around with the microphone. We can get it on the recording and on the streaming audience. But yeah, I just wanted to cover 3 quick tools that I use on basically every Python project that I have. So, and this is more going to be at the actual code level. I didn't actually do any slides because, I don't know, I'm allergic to PowerPoint. So to get started, Pipenv is a tool for managing your Python development environment and all of your dependencies within it. It was developed by Kenneth Wrights, who also is the same guy that did requests and a datetime library called Maya. What was the question?
Why do I want to use an environment?
Why do you want to use an environment? That's a great question. Mostly so that you can isolate one version of Python from another version of Python. So I've got application A that has dependencies of A, B, and C, and I have another application that has either the same dependencies or different dependencies, and the versions might clash or conflict. And so Pipenv can help you manage those types of dependencies. It wraps around virtual env. So virtual env is a tool that helps you manage Python environments. So this is kind of a level above that. It also has facilities for like managing a distribution. So if you actually wanted to build up a distribution, it's not designed specifically for that, but you can create a package if you wanted to. But it's more designed as a developer tool to manage what versions are installed, what versions are locked to, and so forth and so on. So as an example, if I can get started here, I'm creating one for Python 3 on my, Sure. Is it okay? Bigger yet? So now we have a pip file. And you can think of this if you're familiar with other languages like Node.js or Ruby, where you've got a file that defines dependencies for your given application. It's really designed for the application level. So if you're a package maintainer and you're trying to maintain, say, requests itself, you're really only going to check in this pip file. But if you're like me and you're more of an application level developer, you're going to also check in a lock file. So if I say, install requests. This is going to go to the internet, download the requests from PyPI, install it locally here, and now I have a .lock file. So if I look at the pip file itself, it just defines that I need some version of requests. But if I look at the .lock file, it defines the exact version and the exact file hash of the download that I downloaded at the time that I created this lock file. And so me as an application developer, I'm going to check in both of these files so that my coworkers or that the next guy that wants to maintain my application can download the exact same versions of my dependencies and get the ball rolling with his version of the application. Actually, there was a couple other things I wanted to show over here real quick. So if I do other nifty things like graph, it's not very interesting since I have a single dependency, but this lists out all the dependencies that I have for this particular application. If I had other things that depended on certify, or if I had other things that depended on requests, you would see kind of a tree of dependencies underneath each of your dependencies here. You could use this if you got an error from installing a pipenv requirement. It would say, hey, you might want to run pipenv graph, which is what I just did here, and inspect the situation. So you would do something like my skip lock, if I could type correctly. I didn't at all. I really can't type. It's a great presentation so far. So this will just install Maya in my virtual env on my machine, but it won't actually run the lock. And in fact, it errored because I still have Maya in my pip file, which is another great example that I wanted to cover at a later point. But we can see that since I incorrectly typed it, it tried to add it as a dependency here, but it couldn't actually find it on Pipenv. I'm sorry, on PyPI. So in this situation, I would uninstall MYAYA. It'll remove it from my pip file, and it will try and lock the rest of my dependencies. And so now it successfully was able to create a new lock file. If I decide that I am done with this particular version of this virtual environment, I can say --rm. It will know where I've installed previously this virtual environment on my machine and will remove it for me. So it manages all that stuff that used to be managed by virtual env wrapper, so that type of maintaining Python dependencies. So this wraps above that layer and above PyPI so that it's trying to provide that level of abstraction for you. Also in this file, do I still have it? Yeah. Another useful notion here is being able to separate dev packages from your production packages. So since I'm developing on a Mac, I can install things like Mac FS events so that they're Mac specific, versus having to need that installed on my production server, which is not going to be Mac almost certainly. Additionally, there are additional sections here. This is a TOML specification file, so I don't really know the full spec of that, but you can peg it to a specific version of Python. You can also have pre-release dependencies here if you have something that's not quite out yet, like black formatter for Python. All of the code I'm going to show here is already on GitHub, and it's at the repository listed here. You can find my GitHub from my website, jamesralexander.com. I've also built an app that I'll show here, hopefully in just a few minutes. But with this, I wanted to move over away from Pipenv, unless there's other questions about Pipenv before I move away from that. Sure, go ahead. The difference between Pipenv and the built-in what environment? And the built-in VM. It wraps around that. So VM still exists, and you're still creating virtual environments for Python, but Pipenv is managing what is installed within your VM environment.
Could you maybe show how to install a specific version for this? Just to show that.
Sure. Well, we'll see if I can type. I don't know. I wasn't doing so well earlier.
We all believe in you.
Let's see. I don't know if it'll let me install a bad version of request or not. What is it? Double equals? I'm looking at someone that knows more than I do. And so what are we at, like 2.19? The documentation for Pipenv itself is pretty good. They're on Read the Docs. And there's much more examples on how to use it. Their help is pretty good too. So if you wanted to do like security checks on anything, I think this version of pip requirements might have a vulnerability. So yeah, this particular version of requests actually has this vulnerability, HTTP authorization header vulnerability. So that's why you want to install the latest version and not the version that I just installed. But if I cat my lock file, I should see, come on, drum roll. All right, request is now pinned to version 2.19. Any other questions on Pipenv? which is, I pronounce it Pipenv. I've also heard it Pipenv. I've heard it, you should not say Pipenv, but Kenneth says Pipenv, and it works well enough for me. All right, moving on to Pytest. To give you a sense of what my environment is already, that I've pre-baked last night. I've still got requests. I've got black here, although based on all of the changes I made to my VS Code editor here, we won't actually see the correct formatting. It kind of overrides a lot of that. Mock, Pytest watch, coverage, and the plugins for Pytest to make coverage work. So Pytest is one of the unit testing libraries in Python. There's a built-in one, which works great. I tend to think that has a little too much boilerplate code for my taste. You have to create a class, you have to refer to self a lot. Nothing wrong with it, but as I get older, I find that the more keystrokes I have to type, the more my wrists hurt, and there's a finite number of keystrokes I have left on my wrists. So anything that'll reduce the number of times I have to hit the keyboard, I'm all for it. But that said, Pytest will work with unit test files. So it'll still read all of the same nomenclature that a unit test setup will read, and it will still run those just fine. So right now I have some tests in here. Pytest operates very much by convention. So I have a single file in here. I suppose I should talk about the app that I built. This is a very Mickey Mouse type of thing. Over the weekend, I don't know if there's any golf fans in the room, but there was some people that played some golf. And then last week, some guys in my office said, hey, let's make a pool on these people playing golf. And I said, all right, why not? And then I said, all right, I'm going to write some Python to track the scores, because the open.com has a JSON feed of all the scores and all the players. And so I wrote a little app that will keep track of my scores and the other scores of my co-players at work, so that the guy that's keeping the spreadsheet doesn't fudge the numbers at all on me. So anyway, if you're not familiar, golf has 4 rounds. After the first 2 rounds of golfing, the golfers will get cut based on metrics of how many golfers and so forth. In our particular pool, you need 4 golfers to play, so you pick 6 at first. As long as you still have at least 4 through the weekend, you can still play, and your lowest 4 golfers score is what's counted. So Pytest reads by convention anything that is in a test folder or has a test underscore file name on it. So here I've just got a single file because, like I said, this is a very Mickey Mouse example. And I've got a single test that does basically all my things. This is kind of more of a pre-built thing that I've already kind of put together. There are much simpler examples of how to write your first test on Pytest. I wanted this to be kind of a more ready example that you can copy and paste and start using in your applications. I can dig into more about how mock patch works, and I think it'll be a little bit more clear as I get into this. But basically, I just want to say, all right, test a round score, and with this parameterize, I'm passing in a list of expected scores that I've got just hard-coded defined in my module here. I've pre-coded a lot of this so I don't have to live code. We've seen already that I cannot type in front of an audience. And so that's what I want to show now. I just ran Pytest itself, and that'll run it great by itself. I have 1 test, it's passing, fantastic. My preferred workflow for this is to use Pytest watch, PTW, so that now it's just running in my terminal, and then any change I make to a Python file will be detected, and it'll get rerun. So one of the most satisfying experiences I have as a coder is having this workflow of having green tests, making a refactoring change, having red tests, and then fixing the tests, either the application code or fixing the tests themselves. It's this notion of red-green refactor, where now you have red for failing tests, green for passing tests, and then you can refactor it to have it increase readability or restructure it. And as long as your tests still pass, you can be relatively confident that the business logic is still functioning the way you expect it to. All right, so I'll just carry on here. If there's any questions about what I'm doing or what's happening, just raise your hand, and we can address those as we go here. So this calculate score, as I mentioned, for a given player, and at this case, a player is a Leaf employee, not a golfer. It's distinguishing because I confused the two when I was creating this example. So players.json here is the actual golfers, not the Leaf players. So I apologize for the confusion there already built in. But we're basing this on a dictionary that I've got hard-coded. So the main keys here are my coworkers at Leaf. And this is a perfectly robust, no problems with this at all, hard-coded string of last names of golfers that are on my team. So that's what we're starting with. I do a lot of setup to parse out the JSON that comes from the open, and there's a lot of logic in here that I cover with my tests, but is not really important to the logic of calculating a score for a test. So I'm kind of ignoring that, brushing it under the rug. It's all on GitHub if you want to see it and dig into it. But suffice it to say, I got it to work eventually. So version 1, I just have a hard-coded Embree score for round 1 is 42. So we're great. Typically, though, when we look at this, we're going to say, hey, his scores should actually be what's representative of the scores from the game. So they should be some kind of total. And so if you look at his round 1 score for the 6 golfers that are in his list, they actually total up to be 423. So if I get rid of this and I go down to here, version 2, so I'm going to calculate scores looking at each of the golfers in his list. So my GetData is the here be dragons, doing a lot of JSON parsing, putting it into a different data structure that has a list of names and a list of golfers for each name. Then for each golfer, I look at what golf round we're looking at, round 1, 2, 3, or 4, and then summing it all together. And then yay, we're back to passing. So then next we realize, hey, you're totaling all 6 of your golfers and not just the top 4 scorers. And so, okay, we should use the actual score for just the lowest score of your 6 golfers, and let's look at all 4 rounds to make sure that our numbers still match up. So that's what this is doing. I've also got here a note that I'm going to refactor the underlying code because this is perfectly fine, nothing wrong with this. This is the first way I wrote it when I was doing this example. But we could be a little more terse about it and use list comprehensions. So if I get rid of that. So we're still pulling GetData. So now we have a loop that's kind of inside out. So for PN data, player data, return our golfers in a list as long as our name is the name of our player, and give me the first one. So kind of in one line doing a lot of what we were doing in multiple lines in the previous version. An obligatory print statement for debugging because apparently you didn't get that removed. Then we're going to sort the golf rounds, get the first 4 of them, and then sum those together. So what's cool once you get to this point is that so you can remove, say, the whole list, and then now my code is returning the entirety of the list. And so we can see that my test goes back to failing, that instead of the 293 that we expected, we're actually returning 448 as the list of all 6 scores. If we put this back, and then we go back to a green test. Let me pull up the app that I built in Anvil. If anyone hasn't heard of Anvil, it's a way to build Python in a browser. And so this is, I built all of this in a browser, and so it's Python running JavaScript in a browser. There's also a server module here, and that text is tiny. You're not going to be able to read that. But so these are the actual final scores for each of each of my coworkers. And so Embree's, he's got 6 guys that play at all 4 rounds. He's kind of the happy path example. Strangeway, he only had 2 guys make the cut. So most of his guys didn't actually get a score for rounds 3 and 4. And I'm kind of the combination where I had 4 guys, but I only had 4 guys. So that's why I'm calling myself an edge case. So now my tests are failing, saying that my operator less than is not supported between none type and int. And the reason is because I have none scores and I have actual scores. So a version of this that fixes it is right here, where we do our same list comprehension before, checking for just my player, and then we do another conditional inside list comprehension to say, let's make sure we actually have a non-none golf score. Still do the same sorting, and then save this off, and now we got green tests again. What's cool about this parameterize function you can pass as a decorator to your test method is that with this expected scores list, I can just add more and more and more tuples onto it, and they get handed into my test function. So I define player, golf run, and score, and those get mapped to these 3 parameters, which get passed into my calculate score method, which I've been modifying and incrementing versions as I've gone along here. These 2 mock statements are a way that I can abstract away and replace functionality in the target library. So I've got fetch golfers and fetch scores in here. And these are just calling out to JSON, to the open.com, returning a series of JSON with the request library. When I run my tests, I don't actually want to hit the internet every single time, because this is going to run on Travis, or it's going to run on a build server, and I don't want that to happen every single time. So for the sake of my tests, I have some mock functions here that read from files that are stored within the repository. I have heard opinions that using the mock decorator is, I'll say, an anti-pattern or ill-advised. I can see the point of that. I think maybe slightly better as code grows, you want to have some sort of dependency injection or a provider pattern where you're instantiating a class and handing it to this module. In this case, we could probably say, all right, we could create maybe a fetch data provider, and the fetch data has 2 methods: one fetch golfers, one fetch player, one fetch scores. And then as we need those things, we could call calculate score. From calculate score, we would call those 2 methods. Here on the Mickey Mouse example, I just added 2 different mock statements. Any questions on that before I move to coverage? So since I've already done this once already, and looks like I've closed the tab, I can show you the HTML coverage report. But Pytest also has, there's a number of plugins, but a plugin I've added here is for coverage. Let's see if I can type, hang on, bear with me. Coverage report HTML.cov equals. Now I have to specify the module or the top level folder where I want coverage to start reporting. So I got to say the open. So that's specifying the module where my actual business logic code is. And then this will generate, it'll say, well, it should have failed. Let's see, failed report, no data. What did I do wrong here? Do I just need to do that? Yeah, there we go. So this looked at my test file. This looked at my application code and generated an HTML cov folder with this HTML file in it. Since I have a single file that's not really all that interesting, I click into this, and this will show me kind of red and green sections of code that is covered by my tests and code that is not covered by my tests. So all the green lines have been at least touched by my unit tests. The red lines have not. And that makes sense. I'm mocking out fetch scores and fetch golfers, and this gets called basically every single time one of my tests run. It's really just asserting that the JSON I give it still matches the JSON that I expected to get from the open.com. So as long as that still works, then that's going to be fine. And as long as the JSON is the same in the repository, that will never change anyway. This is the code that I wrote to download it the one time, so that's also missed. A little more interesting example is from a Django project that I've got. Typically when I'm going through and I'm trying to increase code test coverage, I'll look at my list of files here, and then I'll just go through one by one. I'll sort by missing. So that'll tell me the number of lines that do not have unit test coverage on them. I've got total coverage on this repository of 87%. My rule of thumb is 80%, because once you get too much above that, your missing lines are basically going to look like edge cases. So I didn't have a test that ever looked at register date is not none. I didn't catch this exception in any unit tests, and so forth and so on. So that's basically what coverage will do for you. Ned Batchelder is working on, the maintainer of coverage, is working on a thing that will include in this report which tests cover which lines of code, so that now you'll be able to see, all right, how many times, well, maybe you'll see how many times has line 176 been covered by tests. Maybe I've got an example like I have in my Mickey Mouse example where every single thing calls it, even though nothing's really exercising it maybe. Or if you've only got one test covering this particular set of code, maybe you want to add more coverage on that particular thing in other edge cases. Let's see, some other interesting things about Pytest. So with my watch command, I can now pass other arguments to what Pytest will be called. So I can say now -k, which is a Pytest argument, and then hand it a name of a test. In my case, I only have one, so it's kind of a moot. But now I'll watch as I did before, but I'll only be watching my one test. So you can see here running Pytest with watching just this one test. So if you've got a suite of 8,000 tests, but you're working on one specifically that's slow or whatever, you can narrow it down and do the same type of auto reloading with just running that one test over and over and over again. You do the same thing with a file. So if you just do test, it would run all tests in that file. Pytest itself has this notion of a durations. So this will tell you the slowest tests that run in your suite. Since I have the exact same code over and over again with different parameters, they're all basically the same, but you might see different tests here that are going to have different running times. So this will tell you, okay, my test suite takes a half an hour. This will tell you where you should focus your energy on which test is slow while you're running unit tests. That's basically all I have. Were there any other questions on coverage or Pipenv or Anvil or anything else I could talk to you about? Like I said, all this code is on GitHub. The link to Anvil is there. Anvil has this notion where you can copy the code of the app. Anvil is a free service, so you can log in with a free account and copy the exact code of that application out and study how I did that there too. So if you're interested in doing that piece of it.
Do you ever find yourself using pip itself, or are you always using Pipenv now?
I try to always use Pipenv, but there are times like when I'm doing my SQL or some other binary dependency where it is just easier to use pip directly. Or if I'm trying to experiment, like if I want to say, hey, will this package work or will that package work? I can pip install it first, see if it works in a test environment or on my unit tests. Then pip uninstall it, or then do a pipenv install. Pipenv will find it and say, all right, you're good already, and I don't have to do anything further with it. So on edge cases, I do still use pip install, but I try to use pipenv itself more often than not.